It is a reverse proxy which is listening on port 3000 and forwarding every request to the localhost port 80. And it is a very basic reverse proxy that I have built using Golang, and this is what I'm going to talk about today. I'm recently learning Go, and I started with a tour of Go, which is a very comprehensive documentation on Go. It is not a lot long but decent sized, so you don't get lost into the maze of documentation, but you can easily start learning Go from here. So that is what I did, and I have the basic idea of Golang, but I wanted to build a project on which I can use my skills so that I learned the skill of problem solving using Golang. So that is why I started building this project, and which is a go through proxy. I have named it go through, and the name is inspired from Geo, which is Golang, and through means you are going through the proxy to reach the backend server. To get the basic idea of what is a reverse proxy, it sits between your client, could be a browser, and your backend. It takes the request from your client, let's say browser, and it forwards it to your backend. Why it is used though? It is used for various purposes. It can be used to load balance the request between multiple backend services. For example, you have multiple backend services, you want to load balance the request to both of them. Number one. Number two, you can have a centralized place of your certificate. For example, client can reach reverse proxy which has all your valid certificates, and it can then talk to its backend services. So that's one or two use case. There are multiple use cases of reverse proxy, but let's just settle down with a very short introduction of this, and I'd like to talk about how I'm building and how this is working. So I could be wrong or could not be the best practices I am using. And that's because I'm new to Golang, and maybe I don't know the best practices yet. So but I will explain what I have did and just go through the code and the basic idea. I will not bore you by talking about each and every line. I will just talk about the gist. So I'm using a configuration file to take the config from user, where I'm defining this is a layer 4 proxy config. Here you have servers definition, so you can have multiple servers. For example, you can listen on port number 5000 as well. And then under each servers and under each listens, there are backends to which I want to forward my request to. I can have multiple backends as well. So I can have two different backend, maybe running on two different port, and also different IP addresses, doesn't matter. So according to this configuration, now it will listen on port number 30, and any request coming to port number 3000, it will forward it to these two backends. And same thing goes for this 5000 as well. It will also listen on 5000 and forward any request to um, local IP address and port number 80. So if I do go run now, after I save this, as you can see, it will listen on the ports that I have specified, port number 3000, 5000, and it will forward my request according to the backend I have defined. So now this is the basic working of go through proxy, and the code looks very straightforward. It will read the configuration. It will read the configuration file and put it in a variable of config, and it will pass this config to each and every functions that I'm using. I have something called as L4 handler, which will be a Go routine, and this handler will start all the backend port handlers. For example, if I have defined multiple servers, let me open this here. Yep, I have multiple ports listening to it, 3000 and 5000. So this will handle it. It will start a separate Go routine for each and every port, and the Go routine will start listening on the specified port. So as you can see here, the listener has a TCP network type, and the config.listen is coming from here. So it listens on port number 3000 for the first loop, and again in the second loop it will start listening on the port 5000 and port 5000. And now since the listeners are up and running, we now need to take care of backends, and for that we have a separate for loop which goes through the listen.accept, and it restarts the TCP handler. So if there is anyone requesting on the, let's say, 3000 port, it will accept the connection and start a TCP handler for that connection. The TCP handler is what that makes connection to our backends. You can see in net.dial, it will dial to configuration and port number that we have specified. Now the main magic is these functions, these pipes. These pipes are the thing which is acting to transfer data between backend and the client. So here you can see this is the connection, the client connection, and this is the backend connection. So this, if you want to see visually, then let's remove this all. And this TCP pipe is these arrows. So the first TCP pipe is taking the connection from client, and yeah, the first TCP pipe is taking the connection and forwarding it to backend, our backend server. So this is the pipe here. It is taking the request from client and receiving it and forwarding it to our backend. And this TCP, it is taking any response from our backend and sending it to our client. So this is a two-way pipe which is working simultaneously using the Go routines. And of course, we are waiting for both of them. And if everything closes, we are closing the both of these connections and exiting out. So this is how it works. And I'm planning to add some more features which I already have introduced, which is date to round robin the request. Currently, it is not round robining, I would say, yep, round robining between these two backend services. Instead, it is hard coded to forward the request to the first backend server, but I will later on update it. The other thing is health check and forward to healthy backend. So if I also want the proxy to continuously health check on the backend services, and if they are down, don't even forward the request to them. For example, is if this backend is down, I don't want to forward any request to it. So that's the future plan, and I have it on GitHub, so it is open source. If you want to tag along the journey, you can always come and create a pull request or maybe an issue. So that's it. Hope you have learned something from this video, and see you in the next one.